Okay. Hi everyone. I am Kubilay from Huawei Turkey R&D Center. I am working as AI engineer with my team. Actually, we will today talk about Ascend full stack AI solution. And in my presentation, my colleague Serkan and Alper will help me. Actually, Serkan will cover last 3 sections and Alper help us to make a couple of hands-on. So if you are ready, we can wear your seat belts and start to fly, because we will talk about very excited topics. So let's get started. Our contents today, actually we will talk about Huawei Vinci architecture and Atlas products. But first thing first, I will explain basic AI. For example, what is AI, and I will introduce a little bit AI history. And then I will explain what is machine learning, deep learning, and I will give difference between this approach. And then we will go through Huawei solutions. And after my section, I will give a couple of hands-on example. Actually, it is inference example. I can say it is like NVIDIA CUDA. Actually, we have ACL framework, and we can run our model on our MPUs. I know maybe MPU is so new approach everyone, because everybody knows GPUs, but don't worry about it. I will explain whole details. Let's start our presentation. As you know, today every sector and every new technology device have AI in it. And I don't know if you felt it before, but now AI is becoming a necessary of our lives. Let's dive into AI and discover what is it. As you know, basically AI is thinking ability of machine. I mean, it gives statistical results according to input values based on what it have learned before. That's why we can say like a little child, something like that. Let's look at its dictionary meaning, because I want to explain more theoretical. When a question is directed to AI, the question given or defined before choose and present the most relational one among the answer. For this reason, every time the question comes up, AI filters the answer to the question and present the most relational one. AI doesn't know what the other person looks like or what it is at first, just like a child, as I said, when learning new object. Over time, it learns by experiencing through the objects presented or by the method of reward and punishment. So, as you can see on right side of page, this is Alan Turing. Have you ever heard that Alan Turing? I don't know, maybe you know, maybe you don't know, but Alan Turing is known to be the father of AI. He raised a question: can machine think, or can AI think, something like that? And then everything come to light about AI. So let's move on next page. So in this page we will talk about AI, machine learning and deep learning. As you can see on this page, actually AI, machine learning and deep learning are closely related. There are some important differences between them. I want to explain this because so many people think that AI, machine learning and deep learning are similar things. For example, when we talk about machine learning, we say this is a deep learning or this is deep learning example, something like that. Maybe it can be true because as you can see, machine learning includes deep learning or covers deep learning. But let's explain more details. Briefly, AI embraces everything about making a machine think and act like a human. Machine learning and deep learning are subsets of AI and are used to achieve the goals of AI. Let's explain what these are exactly. AI developing machines to mimic human intelligence and behavior. Machine learning means algorithms that learns from structured data to predict outputs and discover patterns. That means machine learning needs future engineering. But when it comes to deep learning learns from unstructured data. That means it doesn't need future engineering, something like that. That's why everyone think deep learning more close human brain, something like that, because this algorithm based on highly complex neural networks. Let's move next page. And this page we will talk about basic process of AI development. I would like to explain how we develop AI algorithms from the scratch. Basically, AI developments includes 5 stages. First thing first, we need to determine an objective. Actually, it is actually main goal before starting a work, maybe job or maybe studying. We need to determine an objective for every work. That's why before starting data analysis, we have to determine what to analyze or who is your data object, what problems do you want to solve, and so on. After that, we will preparing data according to determine an object. Data preparation refers to data collection and pre-processing. Data preparation is the basic of AI development. When you collect and integrate related database on the determined object, the most important thing is to ensure the authenticity and reliability of the obtained data. I mean, we cannot collect all data at the same time. In the data labeling phase, you may find some data source are missing, and then you may need to adjust and optimize the data repeatedly. So third phase, training a model. Model training involves analyze the prepared data to find causality, internal relationship, and regular patterns, providing refers for commercial decision making, something like that. After model training, usually one or more machine learning or deep learning models are generated. And these models can be applied to new data to obtain predictions and evaluation results. A large number of developed and trained the models required by their servers based on mainstream AI engines. Mainstream AI engines means TensorFlow, PyTorch, maybe MXNet, something like that. Next step, evaluation the model. You know, we have maybe a lot of model, but we don't know which one is the better for our solution. Maybe some model is has bad outputs or bad accuracy. That's why we need to evaluate the model. We are struggling statistic results. That's why every step we need to evaluate our progress. So the entire development process is not completed even though you have obtained a model, because the model needs to be evaluated, as I said. Typically, you cannot obtain a satisfactory model after the first evaluation, and it may need to repeatedly adjust algorithm parameters and data to future optimize the model. So some common metrics such as accuracy, recall, and so on help you effectively evaluate and obtain satisfactory model. And after collect or after get this satisfactory model, we can deploy the model stage. This deployment stage based on existing data. After a satisfactory model is obtained, the model needs to be formally applied to actual data or newly generated data for prediction, evaluation, and visualization. The findings can be reported to decision makers in an initiative way, helping them develop the right business strategy. So let's look at the bottom of page. As you can see, there are two different process. It is model training and model deployment. This two process is so important because Huawei solutions separate these two process for different chips. So what is model training and model deployment? Model training covers, as you can see, parameter tuning, competing model validation, something like that. And on the other hand, model deployment covers crop, quantization, and also AI service. Model training means that we have algorithm and data set, and it learns the necessary information from the data and put these parameters into model training. So model deployment, or maybe we can say model inference stage, that we have a model and unknown data, and the pre-trained model can predict outputs according to our unknown models. So that's the thing of behind AI development. Let's move next page. And I would like to explain a training set and a test set. We need to separate our data sets two parts, and training set and test set. So because as I mentioned before, we need to evaluate our models after training stage. That's why we need to test set. That means our AI model or our algorithm doesn't know our test sets, but our algorithms train on our training set. So training data sets use in the model training stage, basically. On the other hand, the test data sets use to evaluate or test the data after model training or specific batches. According to this, we will learn our model's recall accuracy, something like that. So let's move next page. And I would like to explain two bottlenecks in model training stage. This is underfitting and overfitting. What is the meaning of these bottlenecks? Actually, overfitting happens when a model learns the detail and noise in the training data to extent that it negatively impacts the performance of the model. So this means that the noise and random fluctuations in the training data is picked up and learned as concept by the model. Actually, if we have an overfit model, we can get really good result on training data set, but we cannot good output or good accuracy on test data set. That's the meaning of overfitting. And another bottleneck on AI, underfitting. Underfitting refers to model that can neither model the training data nor generalize to new data. That means we cannot, actually it is related to our model is not compatible with our model data, or our data is not enough for our model, something like that. Because after training and also in the training stage, our models gives bad accuracy or bad loss, and also after training, if we need to test our models, it will give really bad results. So let's move on next slides. After a basic AI approach, I will move our Huawei Ascent AI solutions. So what is the Huawei offering for this problem? Basically, Huawei is a hardware provider and has really good tech stack about it. In addition to this, Huawei thought that it needs to create full stack AI solution covering hardware on the bottom, software on the top. Let's move next page and see our architecture. Yeah, this is Huawei Vinci architecture, and actually our MPUs includes Huawei Vinci architecture, and Huawei focus on AI computing power. I mean, you know, normally we are using GPUs, and GPU means graphical processing unit. And as you can see, actually GPU was developed normally for graphical process, as I said. Thus, it calls graphical process unit. If we look at more closely GPU architecture, we can see that it contains more area scalar vectorial units than cubes tensor cores, as you can see. But this situation is the opposite MPU. Actually, MPU means neural processing unit. This is our chip, and our chip includes Vinci architecture. So that's why Huawei more focus on AI and saw that AI models are mainly based on the convolution neural network and which are generally based on matrix multiply operations. That's why our Huawei Vinci architecture includes 88.7% matrix multiply operations. It's cubed stage, and also we include vectorial and linear parts. But as you can see, on the GPU we have just cube stage. Actually, NVIDIA calls tensor core. On the other hand, scalar stage includes more area. What I want to mean this approach. Actually, as you can see, bottom of the page, we have a table, and it explains that we can deliver same computing power on NPU are smaller than GPU area. I mean, for example, GPU has 5 millimeter square and NPU has 13 millimeter square chips area, and this has following computing powers. So when it comes to our to efficiency ratio, we can see that Huawei NPUs having Vinci architecture provide 2 times power of GPU or other AI chips. So and what is the and after that we can use less energy with this architecture, because we have more smaller chip, and we have big AI computing power in the same area. That's why Huawei NPUs can deliver more computing power with tiny energy consumption, something like that. So this is our 2 chips, AI chips. Actually, we called left of the page, this is Ascent 310, and it is based on inference application. And right of the page, it is Ascent 910. It's developed based on the training application. So why Huawei choose develop 2 different chips for training and inference? So because Ascent 310 offers ultimate performance per watt, and it's designed for edge inference application. So it used the 12 nanometer process and provides up to 22 tera operations in 8 power computing, and also it provides only 8 watt power consumption. This makes it a perfect choice for edge computing. I mean, if we choose maybe our chips provide training features, also maybe we cannot deliver with this power consumption. That's why Huawei choose separate two approach. So when it comes to Ascent 910, Ascent 910 AI processor supports industry highest computing density of a single chip, which is applicable to AI training. Of course, you can use it for inference application, but it will be rest of resources, right? It is so power for inference application, and it use more. It needs more power consumption. So when it comes to its feature, it's use 7 nanometer manufacturing process and provide 512 teraoperations computing power with a maximum power consumption of 310 watt. So in that way, Huawei aims to provide efficiency in terms of energy and silicon technology. So let's move on next page, and we can overview of the Huawei Ascent full stack AI platform. So actually this is overview of Huawei Ascent full stack AI solution, as I said. And as you can see, the table explains Huawei Ascent AI solution from device level to application level. So today we will explain some of Huawei full series hardware solutions and Huawei CANN heterogeneous architecture. It's like CUDA. And Huawei MindSpore frameworks. It is full development AI architecture, and also we will explain Mind Studio. It is a full development toolchain for AI application, and then we will explain Mindix. It provides end-to-end solution on high HPC infrastructure. So apart from this, you can see on the table is a tool called Model Arts. Model Arts is a cloud tool manage a full stack with the low-code, no-code approach. I mean, if you don't want to use these on-premise products, you can go our Huawei cloud, and then you can buy some training hours and then use model hours easily, because you can train your model with writing any code or something like that. So let's move next page, and the next page about Ascent AI processor and as I said previous page, I will talk about our some products. Let's examine our specific solution according to three different scenarios. First thing first, I want to say that every product includes different piece of these two chips, Ascent 310 and Ascent 910. As I said before, Ascent 310 for inference application, and Ascent 910 for training application. And as I said, we can use Ascent 910 for inference as well, but it is worth of resources. So let's look at our Atlas 200 AI accelerator model. Atlas 200 AI accelerator model includes just one Ascent 310 AI processor. So, and it provides just 22 tera operations in 10. When it comes to, actually we cannot see these products on the page, but when it comes to Atlas 300 inference card, actually this is Atlas 300 training card. I mean, it looks like this, but it is a little bit different. This inference card includes 4 Ascent 310. That means it has 88 tera operation in 8 and support real-time analysis to 88 channel full HD videos. On the other hand, our Atlas 300 AI training card, this is our card, so has just one Ascent 910 AI processor, which is the most efficient card of industry, and it provides 640 tera operations in 8. So other remaining device like Atlas 900 AI cluster, Atlas 800 AI training server, something like that, includes combination of this Atlas 300 inference card, Atlas 300 training card, something like that, or just includes our Ascent 910 AI processor. So, for example, Atlas 800 inference server supports up to 8 Atlas 300 inference card. That means it provides 704 tera operation in 8. Yeah, something like that. If you want to know more detail or products, you can follow our highascent.com website, and you can pick a lot of details about it. So when we have talked about AI computing power until now, however, I would like to explain their energy efficiency or other competitive features. You know, Huawei Atlas products have really heavy, higher energy efficiency ratio can greatly reduce the overall operating expense of the data center. Specifically, the Atlas cluster is the industry first full liquid cooling AI cluster. It adopts unique design such as board level liquid cooling and cabinet level air liquid head exchanger. It saves a large amount of efficiency fees for power usage efficiency of data center. So let's move on next page. So as a result of actually I explained our cards or our products, but let's compare other products like GPU and other processor. And as a result of test carried out, Atlas device and also Ascent chips verified that Atlas 900 provides our more computing power, as you can see on the table and this graph. That NVIDIA V100 on the ResNet 50 with the ImageNet data set, and also Atlas 800 training server provides high computing power by estimating parallelism between chips. Actually, it is related to our hardware infrastructure and also our software infrastructure. Until now, I tried to explain our hardware infrastructure, but now we will dive into our software infrastructure. This is CANN, like CUDA. The meaning of compute architecture for neural networks. Before start that, maybe if you have any question from this part, you can ask me and I can explain, because we will pass new part, software part. Yeah. Any question for now? Okay. Yes.
I guess it's like a neural network chip.
Sorry?
Is it in a neural network chip? Can you add something about that? What is it?
Can we? Sorry, I didn't understand.
My question is, what is the Da Vinci architecture just you mentioned?
Actually, Da Vinci architecture is like, you know, normally GPU has, what is the name of architecture on GPU? Actually, I forgot the name of architecture on the GPU, but Maxwell, yes, Maxwell. For example, GPU has Maxwell architecture. That means it is related to designing of chip. For example, chip providers design their chips according to this architecture. This is the meaning of architecture, and as you can see, this is GPU, and it has tensor core, scalar core, and vectoral core. But scalar and vectoral cores has more area than cubes, and also actually this is tensor core. But when it comes to our side, we have a cube architecture, cube cores, not tensor core. This is completely related about chip designing. Actually, I am not expert of chip designing stage. That's why I cannot explain more deeply. But I can say just this.
I mean, let me say this. I think it's matrix multiplication is the main operation in deep learning. But if you see the traditional NVIDIA architecture, it caters to not only AI but also HPC. It supports single precision, double precision. So there's multiple units. The area of the die is used for multiple things, just not only for this simple matrix multiplication, which is the main workload. Whereas it just these TensorFlow supports three-dimensional small matrices, whereas the Da Vinci architecture can support 16 by 16 by 16, huge operations at single instruction, multiple data. So you can, it's like vectorization, but you can do this single matrix multiplication of dimension 16 by 16 by 16 in few operations through this hardware support actually. Yeah, that's the main thing which is pushing, and we have very less support for scalar and vector units.
Yes.
And more of matrix units actually.
Yes. Because of it. Please.
I saw that your product had a very far and good efficiency than NVIDIA, and a
Yes,
data?
yes.
And what was your evaluation method, or how did you, reach to this efficiency and calculation? What I mean?
Actually, this is related to our architecture, the Vinci architecture, and also our CANN, like CUDA software architecture. We focused more AI computing. You know, GPU developed by maybe, I don't know, maybe 30, maybe 50 years ago. I don't know. I'm not sure. But first, in that time, GPU focused just graphic processing unit. That's why it still includes graphic processor. For example, we cannot use our products for graphical process. I mean, you cannot use our products to play a game or to render video, something like that. We can just focus AI capability, something like that. That's why we include more matrix multiply operations rather than vector and scalar operations.
No, what was your evaluation method that you showed them?
I see. So let's. Actually, this is the institute, and the institute compare NVIDIA V10 and Ascent 910 chips using same backbone ResNet 50 and also ImageNet dataset, and they applied a couple of tests according to test scenario. For example, there is just one parallel processor, and NVIDIA use floating point 60, and it gives 1276 FPS, and other side, our Ascent 910 gives 1846 FPS. I mean, we try to evaluate these two cards using same architecture and same data set, but this test applied from an institute in China, and according to this we collect this result.
When they're calculating the number of images processed per second, I think ImageNet processes images in batches. So the more images you process per second, the better your performance is. So that's what the number is quoted. So it's and I think it looks like it's at least twice better.
So do you mean which kind of algorithm evaluate this two processor? I mean, because as I said, we used ResNet 50 and also ImageNet as a data set, but actually we applied evaluation approach for AI, and we collect this data. I'm not sure it's clear or not for now.
Maybe I can ask later. Yeah.
Okay.
I guess we can go to CANN.
Okay.
We'll try to finish at 11 for the break.
Okay. Let's see CANN now. I have, as I said, I have tried to explain Huawei hardware infrastructure about AI until now. And now we will move on to software infrastructure stage, which is maximize the performance of Ascent chips. So let's move on next. Next page, and explain what is the CANN and also ACL. So CANN means Complete Architecture for Neural Networks. As I said before, it helps to manage Ascent hardware infrastructure using hierarchical APIs like ACL. In this way, user can build AI application and service based on the Ascent platform. So CANN provides device edge cloud synergy. I mean, for example, we have a model and we adapt our infrastructure. After that, we can deploy this model on all product side. I mean, we can deploy this model on device side, on cloud side, and edge side. So it brings efficient deployment with ACL, ultimate Ascent compute power, by unleashing ultimate hardware compute power. So let's look at the table on the left side of the page. The table explains whole structure of CANN. As you can see, bottom of the table talk about CANN advantages and features. Like as I said before, all scenarios, enablement, ultimate performance, simplified development, something like that. And CANN location on the top of this part, it explains CANN location on the device. That means CANN install system has operating system and Atlas hardware. Top of the table talks about APIs and also supporting AI frameworks. As you can see, CANN supports TensorFlow, Caffe, PyTorch, and also MindSpore. I will explain MindSpore next slide. This is our AI frameworks, and actually it's very similar with PyTorch because we affect PyTorch in that time, that I mean 2018, 19, because in that time and also now PyTorch is so big. PyTorch has so big community and so popular. So I mean you can see MindSpore code on our MindSpore website, and you can feel like this is PyTorch, something like that. But it is more powerful than PyTorch because it includes a lot of features, ready to use features. We can we will explain next page. So. And what is ACL? ACL mean Ascent Compute Language. Ascent Compute Language provides unified APIs that adapt all Ascent series hardware to decouple software and hardware. In addition to Ascent CL APIs can be called third-party frameworks to use computing capability of Ascent AI processor, fully releasing and diversified computing capability of the Ascent system and enabling developers to quickly develop AI application. We will cover this its details next slides. So yeah, and also I can explain what is the graph engine, and a graph engine as the controller center for graph compiling and executing. And also I can say what's the runtime manager. A runtime manager provides a resource manager for device and management channel for task allocation of the neural network. And DVP means digital video preprocessing. You know, we can use a lot of people use OpenCV to process video on the CPU, but you know, at the edge side we don't have enough CPU or computing power, but we have MPU, and MPU provides hardware video processing, and you can. Maybe you don't have enough CPU on your edge device, but you can use our MPUs to process your video or your image. Or I mean, for example, you have IP camera and you need to decode and encode something like that, you can use directly DVP. So another thing, CANN. Actually, I explained CANN, but CANN includes sub modules like HCCL. HCCL provides Huawei Collective Communication Library. Actually, it's distributed to model or data between a device. For example, we have a training server, and it has 8 MPUs, and we can distribute our data easily using Huawei Huawei Collective Communication Library, or we can distribute our model, something like that. So maybe we can move next page, and we can dive the details of ACL. Yes, this is ACL overview. As I said before, this is ACL means Assent Compute Language. It provides a collection of C language APIs for use in the development of deep neural networks, inference application on the Assent platform. So these APIs are designed for device context, stream and memory management, model and operator loading and executing, as well as media data processing. I mean, I explain a lot of features about MPU, but at the end of the day, we need to use this feature using maybe Python, maybe C++, any kind of programming language. But now we just support C, and Python high-level APIs using ACL. I mean, you can manage your device using ACL. And you can load your model, you can execute your model using ACL high-level function. So let's move on next page, and we can dive application development on CANN. So as you understand, we will use this page ACL because we need to we need to use high-level functions, and ACL provides this for us. So let's look at this page. Developing AI application based on CANN platform is common scenarios such as target detection, image classification, image processing, speech recognition, and online translation. So how are these applications developed on the CANN platform? We will understand examining this flow chart. So let's take a look at the wizard that summarizes the resources to refer during development. First thing first, these application steps looks like pretty tough, but for beginners. That's why Huawei thought that we can provide models, directly models on the model zoo page. This is repository of Ascent community providers and provides some models trained based on mainstream AI frameworks such as Caffe, TensorFlow, PyTorch, something like this. They can, I mean, you can use directly our model zoo page. In that way, we can skip model preparation stage. I mean, normally we have a PyTorch or TensorFlow or maybe a Caffe model, but we cannot directly use this model on our device. That's why we need to port, or we need to convert these models, and we have a model format that's Huawei compatible model, and it's called OM model, and we are using to convert this model ATC, this Ascent Tensor Compiler. It's easy script or easy tool to convert the model. Just need to know some flag or some parameters. After that, you can put your model and necessary parameters, and then it will do whole process on behalf of you, and then it will give you a OM model. So, but we thought that maybe you want to try easily, or maybe you want to know our infrastructure, and you need to pass directly model execution or application development stage. In that case, you can use our model zoo page. I don't know, maybe I can show model zoo page. This is highascent.com, our website. Hang on, please. I need to translate English. Yes. And you can pass model zoo. Yes. And you can pick your need according to your needs the model. For example, we need maybe ResNet model, and for example, this is TensorFlow ResNet, and this is MindSpore ResNet, and you can click this, and you can find more details about it. something like that. I mean, so let's go back our slides. So so yes, after get our offline model, that means our OM model, we can move application development stage, and you can call as ACL interface to develop application. After application code is compiled, I mean, if you use C, C++ codes, you need to build your code, and you will get a binary file, and you will run your application, and you will put your model you will give your binary model this binary file, and then you will get output. So, but in this stage, maybe we can face some errors because it may occur during the running. That's why before switch the last stage, or before apply our model, we need to use debugging function. We can use the experience logs or tools to locate the problem, and then we can apply fixing, and then maybe it's related to our models. That's why it can need performance improvement. In that case, we have a couple of tools to finalize, to help user to handle performance improvement. After that, if everything is okay, we will pass precision improvement and something like that. We will utilize the model accuracy analyze to debug and model precision problem. And at the end of these steps, we have a really tough or really strong OEM model. Actually, ATC offers after conversion, you will have more. I mean, after conversion, your model has more throughput output. I mean, more FPS. Or more performance, but on the other hand, maybe we can our OEM model has less, a little bit has a little bit accuracy consumption because of the conversion stage, but don't worry about it because it is not so high. For example, you have a model and it has 80% accuracy, and then we convert this model using ATC. At the end of this, we have OEM model has 79.5, maybe 79% accuracy, something like that. It's so small size. And it's acceptable actually, because after this conversion we have really fast model, and we can, for example, we have really heavy model and we cannot run on our edge device, but ATC helps run these models on edge device or on small computing power. So let's move on ATC part. And as you can see, ATC support TensorFlow, Caffe, and also Onyx and Mindspore. I mean, if you have a TensorFlow, Caffe, or Onyx or Mindspore model, you can put your model into ATC, and you can convert your model without doing any specification. Just need to align this flags like model path or weight path, framework number, output name, SOC version meaning of our chips. For example, we have 2 chips, Ascent 310 and Ascent 910, as you know, and etc. There is so many flags, but generally we don't use all of them. You can examine our website as well, and you can find these details. And how we can convert our PyTorch, TensorFlow, and other models to OM models. First thing first, as I said, we need to prepare environment. I mean, you know, we need to have ATC. Actually, ATC actually CANN includes ATC. That's why first thing first, we need to install CANN, and then you can use ATC directly. But before do that, you have to set some environment variables, and you can this step on our website. Actually, this is really good guide, and I believe that everyone can do it on your laptop, on your device, because I would like to explain that you can use this stage on your device. I mean, you don't need. Sorry.
Excuse me, I have one question. What is ATC?
Ascent Tensor Compiler. It is Ascent Tensor Compiler. ATC aims to convert our models to compatible Huawei models. I mean, we have TensorFlow, PyTorch, Mindspore models, but we cannot run these models directly on edge device, especially edge device. That's why we need to convert offline models or Huawei compatible models, and ATC handle this stage for us. Yes. When it so how I mentioned it's you can install our CANN on your device. You don't need our products for you to use ATC. I mean, if you want to try ATC conversion, you can go our website and you can download CANN community version for Windows, and then you can try convert some models. But after that, you cannot evaluate, or you cannot try if it is work or not, because at the end of the day, you have to have Ascent device or Ascent chips, something like that. Okay, let's move on. And this is application development stage flow chart. I will explain end-to-end model execution stage, and then I will give 2 hands-on example about it. One is on one will be on C, C++, and other will be on Python. And we put our codes on our GitHub page. I think before do that, because we will give an overview our hands-on, and after that we will pass hands-on stage. In my opinion, maybe we can give a break, and then we can pass hands-on stage after explaining this flowchart.
Okay, I think I guess we can finish pretty early. Stop for break now. Maybe we can get back at 11:20.
Yeah.
Half an hour break. And then probably we'll go ahead with this. And after break, we have a hands-on.
Yes.
For the hands-on, we'll probably move to a different Zoom. Not today. We also have engineers to help you on each breakout sessions.
Yes.
So we will organize this. But we'll break for next 30 minutes.